the upper end of 3.8 meter long steel wire, so this is the length of the wire, is fastened to the ceiling, and a 54 kilogram object, so I'm going to call it the mass of my object, is suspended from the lower end of the wire. You observe that it takes a transverse pulse 0.0492 seconds, so this is a time, to travel from the bottom to the top of the wire. What is the mass of the wire? So I'm going to call it mass of the wire, and I'm going to add a subscript here because this is our object MO. Now this in the diagram, this is my mass of the object, and then the length is 3.8 meters. Actually, it's better to write L in here. And then let's write the information given for us. L equals 3.80 meters. We have mass of the object equals 54 kilograms. Time equals 0.0492 seconds for the pulse to travel from bottom to top. And then we're looking for the mass of the object, question mark. Okay, so we are looking actually mass of the wire, not the mass of the object. So here should be wire, mass of the wire. Now, how can I find mass of the wire? So mass of the wire is kind of hidden in the linear mass density. So if you may remember the definition of linear mass density, that's a mass of the wire over the length of the wire. But then linear mass density is in the velocity, in the speed of the pulse, which is square root of force of tension divided by the mu. So if I can find the mu, and then I can find the mass of the wire from the top expression. So my goal is now to find the mu. So to find the mu, that seems like to be difficult because I do not have the speed and I do not have the force of tension. Well, maybe we can do something about the tension by using the equilibrium conditions. So there are forces acting on this object. So the weight of the object provides the tension in the wire, so force of tension. So from here I can find force of tension equals mass of the object times g. So this question is solved. Now how about the speed of the wire? Well, not the wire, speed of the pulse. To find the speed of the pulse, it's simply the length of the wire divided the time it takes the pulse to travel. So this is solved as well. Now all we need to do, find the force of tension, find the mu from our expression. So let's see, mu would be equal v squared. No, it would be force of tension divided by v squared. Okay, so and then if I plug this one into here, I can find the mass of the wire. Well, let's do that. I can write in here mass of the wire equals length times the linear mass density, and that equals length times force of tension over the v squared. Okay, now we can plug in the numbers. Actually, let's plug in what is the v in here. So it would be L, force of tension. Let's just plug in the force of tension as its expression m object g, and then divided by the velocity would be L over T squared. Okay, now from here I can plug in the numbers and find the value. Let's simplify first. So simplifying, that will give me mass of the object g t squared over just the L, so mass of the wire. Now let's plug in the numbers. 54 kilograms for mass of the object times 9.8 meters per second squared times 0.0492 seconds divided by 3.80 meters. This leads me to, if I punch it into calculator, I got 6.85 kilogram, and I strongly recommend you to do it on your own and check this value. Stay tuned. Thanks for watching.